Chemistry.
Today we're going to answer what a chemical reaction is and why it happens. In a chemical reaction, the molecules called the reactants will, hear this, react with one another to form new molecules called the products. The reactants do this by rearranging its atoms. Knowing that means changes in physical states are not chemical reactions because the molecules do not form into new molecules. As you can see, this is ice, and this is water, and they're both made of H2O. A chemical reaction happens because it favors what the molecules want, or because of the input of energy. In chemistry, we use this equation to determine whether a chemical reaction will happen or not. The delta G you saw refers to Gibbs free energy. It's easy to understand because it's a measure of energy free to do work. Molecules can either decrease or increase their free energy as denoted by the negative and positive delta G. What that means in chemistry is that the molecules are either becoming stable by being less reactive or becoming more reactive. In the universe, molecules are just lazy, like us. Molecules want to be less reactive by being more stable. Now you may be wondering, how do the molecules even gain or lose their energy in the first place? Well, this is where we get onto the next term, enthalpy. Enthalpy is the measure of energy within the bonds of a group of molecules. When energy, usually in the form of heat, is absorbed into the bonds of the molecules, enthalpy increases. But when that energy leaves the molecules, the enthalpy decreases. These processes are denoted by a negative or positive delta H. When energy comes in, it's called an endothermic reaction, but when it comes out, it's called an exothermic reaction. In the universe, molecules will do whatever they can to get rid of that energy. As a result, an exothermic reaction is favored. Remember when I said molecules wanted to lose their free energy? Well, that's the case. In an exothermic reaction, the molecules lose their energy in the form of heat. The next term is entropy, and it's a measure of randomness and disorder among a group of molecules. Molecules with low entropy are organized and shown with a negative delta S, but molecules with high entropy are more disorganized and shown with a positive delta S. And in the universe, molecules not only want to have less energy, but also be more random. With that in mind, we could say molecules in the gas state have more entropy, but molecules in the solid state have less entropy. And the last term is temperature, and it's the measurement of the movement of molecules. If the molecules are moving a lot, it creates high temperature, but if not, it creates low temperature. Normally, molecules will favor certain conditions. However, it varies with temperature. When molecules are at high temperatures, they'll be moving a lot more. Therefore, the molecules will be more randomly dispersed, meaning high entropy. But when molecules are at lower temperatures, they'll be moving a lot less, usually as a result of their heat energy being released in an exothermic reaction, meaning low enthalpy. To show you what I mean, here's this table. A chemical reaction can happen in any of these conditions. It's just that the chemical reactions in conditions that do not favor the molecules can only happen when given energy.